Hello, everybody. Let's get started. As he said, I'm Richard Glazer. I'm the IT manager at the University of Utah Marriott Library. I'm going to give a little bit of background. A lot of times people on the Mac Slack think of me as a scary clown, but there's a face to the madness. I've had over 25 years administrating experience with Apple technology from the original Mac OS Classic and hardware. We were early deployers of Mac OS X, early betas in lab environments. To today, we're deploying 1,500 Mac clients, 800 Mac OS systems, iPad systems. We're also using some solutions that do remote software solutions called Apps Anywhere. I worked with Jamf in the company, and we have a Jamf integration, working with that tool. We're also using a native Mac VDI solution called Aqua Connect to distribute native Mac solutions to non-Mac clients. We're also supporting a ton of other technology. We're doing an automated high-end video recording system, kind of modifying PSU's one-button studio code to work in our environment. We're doing a lot of Surface Hubs, 3D printing, audio-video studios, VR classrooms, digital signage. We're also doing a visualization wall, and we're also doing some RFID classroom projects that we'll make open source and share with the community. Again, our university kind of background, we're really decentralized. Our department kind of does a lot of support for Apple and our backend infrastructure on campus. I work for the main central library on campus. At a lot of institutions, the main central library doesn't do a lot of support. Actually, our support for Apple solutions comes from our library to our campus. Originally, I was part of the macOS Labs Steering Committee, which was a 2001 project, was a multi-institution project. I was one of the steering members, kind of working with Apple to kind of document and build solutions on deploying macOS 10 in a lab environment. I was also a former steering member of the Mac Enterprise project that had notable members like Greg Nagel of Disney Animation and Josh Weisenbaker, who currently works at Jamf now. I've presented multiple places, WWDC, Macworld, O'Reilly, and other conferences. I head a popular kind of Mac admin monthly meeting at our university. We make live broadcasts available, have a lot of the archives available. I'd recommend checking out. We have a ton of content, probably over the past 10 years. As a personal note, I play guitar, and I've played with multiple alternative rock bands. I posted slides. If people are interested, they can go up and check sample music I posted there. I go pretty fast. We have a lot of dense content, but I'm posting all the slides, posting all the links and resources. Also on the slides, there'll be a link at the bottom on the content I'm talking about. So if you go back to the slides, you can easily go find more details about each of the content I'm bringing up. The agenda, I'm kind of covering our history to Jamf Pro, how we integrated Jamf Pro with our previous management system, and how we're currently transitioning completely to Jamf Pro. I'm going to outline some of our tools we've kind of shared with the community and made open source, resource links, and then hopefully we'll have time for questions and answers. First, I'm going to talk about the road to Jamf Pro. Originally, in 2001, part of the Mac Enterprise, Mac OS Labs project, we started deploying Mac OS X Cheetah in our lab environment. We've had about 400 stations running Mac OS X. Initially, there was a solution called ASR for Mac OS X, and we had to use NetBoot to image the clients in Mac OS X. We used a monolithic imaging process. So basically, we had a pristine source image, had to do cleanup, created an image, but the strange thing here is we had to boot back into the classic Mac OS to image a station into Mac OS X. In 2002, we were early adopter of RadMine, which is a probably early Mac OS X file system management solution. People who don't know RadMine, it does integrity check of the local file system. What that means, it's basically running as a tripwire on the system. So what it does is it will compare the local file system against a defined file system on the server and then restore the local client system to the pristine state. So it's kind of like VM snapshots, but you can manage the snapshots on a server. So this kind of shows a workflow for people historically interested in that. RadMine allowed us to move from monolithic to modular imaging. So basically, we could just do a base install image, and then we could have RadMine kick and manage from that point on. And here's kind of an example. We just put like bare minimum images on the system, and then RadMine would kick and do the rest of the configuration and installation after that point. We developed probably 2003 an automation solution using RadMine. With RadMine, we actually created multiple configurations. So we had, say, a kiosk, a lab, a LAD with Pro Tools, a staff, and we could create multiple OSs that were never booted, multiple images on one station. And I still don't think anybody in the community is currently doing something like this. And this was in 2003. And then we were trying to get NetWoop to work in our environment. Our university is really decentralized, and our network infrastructure is really poor. So we tried and tried and tried, and we never could get it working. Here's a page that we kind of documented pretty well for the rest of the community. I even reversed engineered a Mac OS X client to run NetBoot to work in these situations. I document it here if you're interested. But because we use RadMine, and we never had to really re-image the systems, and we could run RadMine on a system and actually run it out of context and fix corrupted items, this development was a waste of our time, so I stopped banging my head against the wall. Next, I'm going to talk about some challenges and integrate that we had with RadMine. First came system integrity protection. Apple released system integrity protection back in Mac OS X El Capitan. RadMine manages the entire file system, even including areas that were under Apple SIP protection. So they conflicted with each other. Since we couldn't really quickly move off of our RadMine infrastructure, we decided to temporarily disable SIP. I'd strongly recommend other people not do this unless you're using a tripwire. So actually using our tripwire, we were actually more secure because we were doing other things that SIP wasn't doing by itself. And here's an example how you can turn off file system protection with a SIP. Next, I'm going to show an example how we automated this across our fleet. To scale this across our fleet, we did it as a process, a part of the El Capitan OS upgrade. So basically what we did, we modified the recovery disk partition. We included a disable SIP script, some launch daemons. To make space on the disk image, we removed Safari. The installer would check the installation. We captured what the installer was laying down before it did the restart, and then we slipped our modified disk image in. Then we modified the install OS X package PostScript flight from Monkey to do our installation. Note, we also had other options of newer OSs that we didn't publicly disclose because we were worried Apple or someone else would use that methodology, so we didn't disclose. We did this in newer operating systems too, some variant of this. An example, Patrick Wardle noted us on his blog, this bypass, and he kind of promoted it and highlighted it. The next challenge we had was with RadMine, the Apple file system. RadMine didn't work properly with APFS. There's a file system object called Apple file system files that did not work properly with RadMine and APFS. We didn't research workarounds to try to force Mojave to run HFS+. We decided it's time to get off of RadMine. So here's kind of our moving away from RadMine, Mishi Tripwire. RadMine development kind of really slowed. The main core developers stopped supporting the project. I helped getting the project moved over to GitHub and tried to get additional owners to maybe do development, but I was really saw that RadMine was going away, so we decided to move completely off. Succession, RadMine's really complicated. It's a powerful tool, but a lot of admins didn't understood how to use it. It took a long time to train them, etc. We wanted to lessen our stack for our group. Our administration wanted us to work on other projects, and RadMine and our associated tools, we had to manage the entire stack. We wanted to look for a solution where we could depend on them managing the majority of the stack, and then we could do other things. With picking Jamf, we thought it was extendable. We could do scripts, extension attributes, and APIs, which a lot of our tools will kind of highlight how we're doing stuff with the APIs. Apple featured directions with SIP, APFS, DEP, and MDM, and now MDM's become more and more required. Looking to Jamf versus other open source tools like Monkey, we decided to go with Jamf. Next, I'm talking about how we integrate Jamf and RadMine. Because our RadMine infrastructure was so complicated, we couldn't move off, so we're trying to integrate the two while we can move off certain functionality to Jamf. The first issue we ran into was open file descriptors. So open file descriptors is how the kernel defines an open file. With RadMine, we ran into issues where the file descriptor limit would error out when we tried to run RadMine through a Jamf policy. We came up with this workaround, and we posted it here. You can modify the limit descriptors by creating two launch daemons to adjust the mounts of the open files, and then we run RadMine through a login policy or a startup policy. And it's noted there at the URL below. The next issue we ran into is enrollment looping. Since RadMine manages the entire file system, file system modifications associated with the Jamf enrollment would get removed. And so we'd have an enrollment loop cycle after every time RadMine would run, it would re-enroll. Every time RadMine would run, it would re-enroll. So to lessen the impact on our server, we would we would just let it enroll all the time. We decided to not have it recon after every enrollment to not impact our database. Removing the MDM profile. We also ran into an issue is we didn't bind to our campus Active Directory because it requires each client to be bound, so we did a generic LDAP bind. The LDAP credentials were stored in a keychain item. Jamf also, with their MDM credentials, stored those in an MDM keychain. So we decided as a workaround, because when RadMine would run, it would remove the MDM, and that would cause issues with the Jamf implementation. So before we ran RadMine, we'd remove the MDM profile and then run RadMine maintenance. Next to our Jamf-only transition, we're currently distributing 10.14.6 with SIF enabled. We're currently using Nomad for a loose bind to our Active Directory on campus. We're currently using Nomad login AD with our custom login window, and there's kind of an example there. We're using device enrollment with Apple School Manager and DEP Notify, and there's an example of our customization. We're using Kenobi for external patch, and NetSys for software update services. We're also using Indes and SCEP. We have a large shared laptop environment. We have 180 laptops. We're doing a classroom laptop project with about 100 laptops, and that's where the RFID project I mentioned is coming into play. But we have that implemented. That took a long time on our campus to get set up because we have a central group that had to support this. About a year and a half we had this working previously. Next, I'm going to talk about tools we've developed and kind of sharing with the community. AE-iOS. This is a truly zero-touch iOS Mac management imaging solution we developed. It's a Python library designed to completely manage and re-image iPad systems. We designed it for a really busy student support staff where they couldn't go in and click on things and wait for things to re-enroll and re-download. So it integrates Apple Configurator, DEP, VPP, and MDM. It's not really tied to Jamf per se, but you could use any MDM if you wanted. Again, it's completely zero touch. You don't have to touch anything on the screen. You just plug it in, and it will re-image the machine. Here's an example of the workflow. A student brings back the iPad they checked out. Our staff just quickly checks it for damages, plugs it into the imaging station. Our software detects that an iPad has been attached using CFG util. It adds it to a queue. It erases the iPad. It installs an MDM profile. It re-enrolls via DEP. Then we use system events to automate auto configurator to install the apps. And we have granularity where we can create groups of iPads and we can install certain apps on different groups and other apps on another group. It customizes the iPad, so if it's successful, we'll put a certain wallpaper. If it's unsuccessful, we can put a different wallpaper. Then it goes through the process and verifies that previous steps were successful, else it will repeat them. It adds it to a load balance system, and then it shuts down the iPad, and then the person can check out to the next student. Next, I'm going to talk about another methodology we developed called AppPlayPin. Jokingly, this is to provide adult supervision to immature enterprise applications. We try to address the following: an app that requires insecure permissions, an app that tries to update after every launch, an app that requires additional pre- or postscript launch configuration, and an app that requires to be launched by a specific user or group. Originally, we developed this back in the early days of macOS 10 with the Classic environment. Classic had security and state issues. And then Classic applications required the system folder to be writable to work properly. This is kind of the workaround we did with the Classic applications. We moved the Classic system folder to a read-only image. We modified the Classic startup to mount the image read-write with a shadow file. The shadow file was stored in user space, so after login, it was disregarded. The next user got a clean Classic setup. And back in the day, you used the HDID util with a shadow file, and then you specify where your shadow file will be stored. Again, quickly is the workflow. You modify the Classic startup. It launches the read-only image, mounts it with a shadow file, launches the Classic environment, and then the user can use the Classic application. We also use this methodology with multiple apps that we ran into issues. Unity is an example, Epic Games, ZBrush, and I could give multiple examples. NVivo was one that wasn't per se a bad application. It was more the company thought we were abusing licensing. The company thought we had the most uses of NVivo in the world, and I explained to them how we're doing it. I gave them key server logs, and I showed them our scripts, but they didn't believe me. So we decided to implement an AppPlayPin model that activated the app during each launch. So the user comes up, searches for NVivo, or finds NVivo for in Finder, they see NVivo. But it's not really NVivo, it's our fake NVivo application. So it goes through the same process. It mounts a read-only disk image. It mounts it with a shadow file. Then we run a pre-launch script that activates NVivo, launches the real NVivo, then the user can use NVivo. So here's a workflow if you want to use this model for yourself on some apps you're kind of concerned about. We have, at this link here, we have a sample Apple script launcher, and we're currently moving this to Python, but for right now we have this Apple script. You download that, you create a read-write image of your application install, you convert it to a read-only image, Then you want to customize our AppleScript launcher. You want to modify the icon to appear as the real icon. You want to modify the launcher name to match the real application's name. You want to modify the bundle short version to match the real application's bundle short version. You want to add your read-only image to the launcher bundle, and then you can distribute that application to your users. Next, I'm going to talk about Blade Runner, which is a framework we developed to automate offboarding deprecated Macs from Jamf. This is a Python application, again, that automates offboarding and also automates secure erase of old Mac systems. It has a TK inner front end to provide a GUI usability for people not familiar with Python. To make it available and genericize it enough for the public to use, we allow it to be configured through property lists and XML files. So here's an example. There's a property list if in your environment you can customize for your Jamf Pro installation. Offboarding configuration you can customize for your environment. In our environment, we use storage and surplus as extension attributes to define the offboarding. We also have Slack configuration that can be customized through an XML file depending on your Slack setup. We also use it for busy or forgetful admins. Because this is an automated system, we'd have this running in another location. Someone forgot they were offboarding the machine, it would send them an ag. We also have search parameters where you can search your Jamf installation from the Blade Runner configuration station. We also have verification built in where you can verify it from the client and the user inputting data to just make sure there's a sanity check. There's also a print configuration which you can completely customize that you can fix to the offboarded system. Next, I'm going to talk about another tool we developed called Cleanup Manager that we use in our environment. Again, it's a Python library that automates file or folder cleanup on a fleet of Mac systems. We use it primarily for home folder cleanup based on age or free disk space, and it's kind of a graphical representation. So for example, say you want to remove old home folders older than 7 days, you'd basically use the following flags. Or if you want to guarantee that there's always 50 gig free so the next user can always log into a system, you'd use this command. To integrate this with Jamf Pro, you basically use our script, you could create policies, and then do scoping. You grab our script and distribute it to your fleet. You grab our script and add it to your Jamf Pro instance. Then you define a policy. We usually run it at startup and logout. And then you scope it to your Jamf Pro environment based on your needs. Next, I'm going to talk about Display Manager, which is a GUI front end, or sorry, a command line front end to modifying the display settings across the enterprise. And here's kind of a sample of what you could do rotating the display. It's a Python library that we developed. It uses Pi Objective-C bindings. We had to find, kind of reverse engineer a lot of this stuff to get it to work properly. So for example, in our environment, we have classrooms that have multiple resolution settings. So we can specify on those individual classrooms that we have this resolution or that resolution. In our lab environment, we use this so we have a default setting for the resolution. So if one student logs in, modifies the resolution really high, the next student, we'd be guaranteed it's back to the default resolution settings. Rotation. We're managing a lot of digital signage, and we figured out a methodology of rotating the display programmatically 90 degrees. So here's an example of that. Also, with our digital displays, we ran into HDMI underscan issues, so we also figured out how to customize that per whatever digital signage display we had attached. So here's an example of that. Screen mirroring. I always laughed when I saw presenters dealing with turning mirroring off and on. It took them a while. If they just used our utility, they could have done it in like 2 seconds. But here's an example we used on our help desk. So basically, you have a help desk person has a Mac hooked up to an external monitor. They want to show someone, they turn screen mirroring on. They don't want to show anything, they turn it back off real fast. Took them like a second. To deploy it to your fleet, you download, again, it's on our GitHub repo. You download Display Manager, you use our sample script, and then you set up scoping and policies based on your environment needs. Firmware Password Manager. This is a tool we developed to kind of update, enable, and distribute firmware password through our fleet. For people who are not familiar with firmware password, it allows you to set a default startup device that prevents people from booting from other internal or external storage devices. It also prevents a lot of the startup key combinations that are listed here. We use two utilities. There's firmware password that's in macOS 10.10 or later. In previous versions, there was a tool bundled with the firmware password utility bundle. Why you should use firmware password? We consider it one of the three important methods to securing a Mac system: strong passwords and policy, file vault, and then firmware password. Why we don't use Jamf is Jamf is set it and forget it. It's really difficult to update your firmware password after you've deployed it. Succession planning. If you have staff turnover, you want to update your firmware password across your fleet so previous staff person doesn't know what your firmware password is across your fleet. Password policy. Some environments require sensitive passwords be updated at a certain X days or X months. We usually do ours every 6 months. Here's the components of Firmware Password Manager. There's the primary script, which is a Python script. There's a control script that allows you to customize it for your Jamf environment. It has text inside there, which is a key file, which includes your current password and your previously used passwords. So we ran into an issue where we had a stockpile of machines that had 15 previous passwords, and we didn't want someone to type each password in. This would automate the process of cycling through all our previous passwords. There's also a configuration text, so you can integrate Slack settings and file locations for your environment. To integrate it in your Jamf Pro, you want to use our control script, an extension attribute, a smart group, and a policy. So again, you just distribute the tool to your fleet. You use our sample script template. You create an extension attribute that contains your current firmware password hash. Then you create a smart group that clients that don't have that current hash. Then you run the script to update your clients to the latest hash. Next, I'm going to talk about Tagboat, which is a tool that manages device records in Jamf Pro. Originally, when we talked about this, we got this funny feedback on the Mac Slack channel. They termed it as a custom set of tools to manage your Jamf Pro custom set of tools, which I thought was humorous. But generally, yes, but for our environment, no. We use Tagboat for inventory purposes only, audits and updates. So here's basically how it works. We have a Python application that launches where the user has to enter their credentials, and then we have a Mac version and a Windows version of the application, so it's cross-platform. Again, it's just an inventory tool for our environment. We could do inventory audits, we can do updates, or adding new records to our Jamf Pro instance. In our environment, we support Mac, Windows, iOS, and iPad systems. It supports multi-levels of access, so read-only and read-write. So certain groups that are just doing auditing don't need read-write access. Other groups that are doing updates of the inventory will need read-write access. For our organization, our decision makers wanted a better option to get overall view of our client landscape. So with our system, you can see all the state based on departments, what Mac systems they have, what Windows systems they have, and what iPads they have. You could also find out quickly and easily the number of systems per user, so that you can make decision makers could decide, does this person's job require that they have a Mac, Windows, and an iPad system? Client system age, we programmatically have an extension attribute that calculates the age of the Mac systems, and on the Windows systems, we use a scripting server that will update the age based on the client's manual entry. And then we use definitions called primary, secondary, and service to define the importance of the system, and then we're planning on tying to key server idle access to know how often that machine's been in use. Why use Tagboat versus using the Jamf tools? In our environment, we have people that are doing inventory-only purposes. They don't need to be trained how to use the whole Jamf Pro instance. So in our opinion, using Jamf, or our solution versus Jamf, would be a lot easier. Recce, it's a tool to add unmanaged device inventory to a Jamf Pro instance. Originally, we used Recon Exe for our Windows systems to do inventory purposes. Jamf had this in the original Casper suite, which offered EA support, PowerShell script support, and other support for Windows systems. We used it only for inventory purposes. It worked great with our inventory system. Everybody's smoothing along, and then Jamf announced they're deprecating it. We went, oh, now what are we going to do? So we decided we would write a replacement for Recon Exe. We communicated and collaborated with Jamf to make sure we were going to waste our development time and make sure it would be supported with Jamf updates in the future. So we currently have this available. It adds or updates system info in Jamf Pro on Windows systems. Gives them the OS version, the RAM, CPU, disks, model, etc., any hardware information. It uses the Jamf Classic API to upload inventory information. Version 1 doesn't support application users or fonts. If you want that solution, it's open source. You can do a pull request and help us out with it. But right now, we're just doing hardware. Again, you can do a compiled version of Windows, so then you can do it as a scheduled job through SCCM. It gives you a Windows GUI, so it's double-clickable application, runs on Windows 7, runs on Windows 10. We also have Slack support, so we can provide reports on issues we've run into. Originally, when we were developing this, we ran into issues on Windows systems with blank serial numbers and duplicate UUIDs. It'll give you feedback in Slack on things like that. Help wanted. We're looking for the community to help us with this project. We've done a lot of development on Mac OS X. I heard other enterprises where they consider the Jamf binary malware, so they don't deploy it, but maybe they want inventory purposes. They could use this tool to provide inventory, but not deploy or enroll people in Jamf. We're also looking for people to develop Linux support. So if you have a few Linux systems, but you want to use Jamf as your inventory, this tool could do it for you. Lastly, we have minimal security with our API user. We're also looking for people that are more knowledgeable in this or willing to help us out to better the security. And that's all of my presentation. Here's the resources. Everything's online. I want to thank everybody for the opportunity to present. Oh, sorry, I'll go back. Sorry if I went too fast. If you go to the applelive.utah.edu, it's our blog post. You'll be able to see the link. And the QR code won't take you to someplace else. I promise. Does everybody have it? Okay. Thanks for the opportunity to present at Jamf. Thanks for everybody who came to the session. I want to thank members of our team who did a lot of this development, Sam Forrester, Todd McDaniel, and Topher Nadoub.